Send me that. You gotta send me that.
All right, if you are ready for the Science at the Stage program, go ahead and head on over to the stage. Again, beginning now, we are starting our Science at the Stage program. We hope to see you there. Thank you.
Put that in there. Put that back in your pocket.
All righty, good morning, everyone. How are we doing today?
Good.
That was pretty good, but I don't know, y'all are in school today. How are you feeling today?
Good.
So much better. My name is Miss Jade. Say hi, Miss Jade.
Hi, Miss Jane.
And I'm a scientist here at Discovery Place Science. Say congratulations.
Congratulations.
It took a lot of work, and you know, as a scientist, I want to know who else here is also a scientist. There we go. That's right. That's right. Yes, but I need to see even more hands than that. I need everyone to raise their hand, saying, "I am a scientist."
I am a scientist.
You know why?
Why?
Because every single day you are utilizing science. So yeah, I'm up here teaching stuff, but I'm also learning just as much from y'all as y'all are learning from me. So, as scientists, I know y'all saw at the beginning of the show, I poured a mysterious liquid inside of this box. Who here would like to place their hand inside this box?
Me.
What? No! Y'all are scientists. Come on, y'all. Safety. Isn't that important? Safety?
Yes.
You know what it is? I'll point to you in just a minute. So I'm going to take this restricted glove, very similar to like our skin. I want to show you what would happen if you did place your hand inside this box. Are you ready to count down from 3?
Yes.
Can I get a countdown from 3?
3, 2, 1.
All right, that was 3 seconds inside of that box.
What's the hand?
So I'm going to do it one more time. I'm going to place our hand inside this box.
Yeah.
Don't learn nothing. So speaking of making sure that we are safe scientists, what am I wearing today that's going to keep me safe?
A laboratory
Yeah.
coat. I really want to touch it.
Yeah, these are specifically called
Like that?
cryo gloves that are going to help me against extremely cold temperatures. What else am I doing that's going to keep me safe? Yeah, I have this face mask because what we're dealing with today is a liquid. So it has the potential to like spray back, so we want to make sure that doesn't happen. What else am I wearing that's going to keep me safe?
The coat.
Yeah, lab coat, very good job. I have on short sleeves, so I want to make sure that my arms stay safe. What else am I doing that's going to keep me safe?
The shoes.
Yeah, are they open-toed or closed-toed?
Close.
They're closed-toed shoes. Are my pants really long, really short?
Long.
Long, even my socks are long. And then my hair, is it all the way up or all the way down?
Up.
All the way up. So who here is wearing every single thing that I'm wearing today? Where are your cryo gloves? You left them in the car?
Yes.
That's okay. So since I am the only one that is utilizing all of the safety precautions, that means I'm the only one that should be behind this line at any point. And that I'm the only one that should be messing with this today. Now, some of y'all have already said what we're maybe talking about, but I want to show you my pocket thermometer. Did y'all bring yours with you today?
No.
It's okay, I brought one for you. Come on, scientist, I need you to bring your thermometers with you. I have this ginormous thermometer here for you. All the way at the top here, we have water boiling at 212 degrees Fahrenheit. Fahrenheit is a measurement of temperature. 212 degrees Fahrenheit. Why would we boil water in our daily life? Yeah, but I heard it. Someone say it again. Yeah, to cook. Very good job. Yeah, so like for making pasta and stuff like that, you need boiling water. Down here, the human body typically stays about 98.6 degrees Fahrenheit. That's on average the temperature that we stay at. And then water freezes at 32 degrees Fahrenheit. What forms
Wait.
when it rains and it's 32 degrees Fahrenheit? This is really important to know that. Because you get out of school. What is it? Yell it out to me.
Hi.
Snow, ice. That's when water is going to freeze. So the freezing point of water is 32 degrees Fahrenheit. Now all the way down here, let's go beyond zero, right? Below zero. Has anyone ever interacted with dry ice before?
I've seen videos.
Yeah, you've seen videos of it? So that's at negative 109 degrees Fahrenheit. That's where dry ice forms. But again, what we're dealing with is colder than anything that we just talked about. It does not occur naturally on this earth. We are dealing with, there we go, good job. We are dealing with liquid nitrogen, which boils at negative 321 degrees Fahrenheit. Can we all say that together?
Negative 300 degrees Fahrenheit.
That's a very good number to remember. Easy way to remember is 3, 2, 1, negative, right? So, super cold. Have y'all ever, is even ice cream that cold?
No.
No, ice cream isn't even that cold. And I'm gonna show y'all, do y'all wanna see what it looks like?
Yes.
Let me show you what it looks like. So I want you to yell out to me some of the things that you observe or notice. Yell it out to me, yell it out.
It's bubbling.
It's bubbles. There's gas, there's bubbles, there's steam. But I'm so confused. Like, okay, but it's cold. So how is it showing signs of boiling? Doesn't boiling mean hot?
Yes.
Right, doesn't that, like, are y'all confused? Because I'm confused.
Yes.
So let's test it out a little bit to see if it actually is truly boiling. Right here, I have a tea kettle. When you put boiling water inside of a tea kettle, what does it do? It makes this really agitating screech noise.
Yeah.
Okay? Now, if liquid nitrogen is truly boiling, like we think it is, it should screech, right? Let's test it out. Listen very closely.
It
Do you
did.
hear it here in the front?
Yes.
Yeah, so there is a slight screech noise that is coming out from right here. So it is truly boiling, even though it is extremely, extremely cold. So what is this that's coming out of it right now? Yell it out to me.
Gas.
Yeah, like a steam, gas. Everybody take a deep breath in, deep breath out. That is like 78% nitrogen. So in the gaseous state, it's all around us. It's constantly around us. And right now what's happening is the liquid nitrogen is coming into contact with the room, which is about 80 degrees, and it's going from a liquid to a gaseous state. Gas is matter. It takes up space. Let me show you. I can fill a balloon.
Oh!
Gas. So it's going to have matter and take up space. And if you add heat to a liquid, what does it turn into? Yell it out. Gas. If you add coldness to a liquid, what does it turn into? A solid. Very good job. So we understand that these changes in states of matter. Are y'all ready to exercise?
Yes.
Yes. I love that. I have these exercise bands. Are they known for being super stretchy or
Yes.
really stiff?
Stretchy.
Really, really, really stretchy. I'm just going to place these inside.
Oh, that thing about to crumble up.
So let's talk real quick about what a hypothesis is. Does anyone know what a hypothesis is? Yeah. An educated guess. Very good job. So a hypothesis
She doing that
kind of
smart.
sounds like this.
She's
If I do this, then this is going to happen. So if I place exercise bands inside liquid nitrogen, then is it going to become more stretchy? Who thinks it's going to become way more stretchy? Who thinks it's going to become less stretchy? Less stretchy? Who thinks, it don't matter, it's just liquid nitrogen, ain't nothing going to change?
Look at the key.
Okay, let's
the
test
key
that
cutter.
out.
It's frozen.
Let's see here. So I've had those exercise bands in there for about 30 seconds. Are we ready to hear? Oh, man. I mean, I was really trying to work out today. I shouldn't have done this. This is so silly of me. Man! How am I supposed to work out with these? What am I supposed to do now? So we can see here that it's hard as a rock. And as it's coming back into contact with the room though, again, the 400-degree difference in temperature, when it's put inside the liquid nitrogen, it zaps that warmth, which takes away the stretchiness and the flexibility and the elasticity. But as it gets exposed to its room again, it's going to become stretchy again. It's just going to take a little bit of time. Similar, I have 2 bouncy balls. Pretty awesome. I'm just going to place one of them inside. So let's talk about real quick the difference between an experimental group and a control group. The experimental group is the bouncy ball I place inside that box because that is being part of the experiment. The control group is the one that I'm not messing with at all. Let's form a hypothesis. Who thinks it's going to become way more bouncy? You think so? Okay. Who thinks it's not going to be bouncy at all? A lot more hands raised. Okay. Who thinks it don't matter? It's liquid nitrogen. Okay. Awesome. Let's test it out. Let's see it here.
You better. And your crush
right.
watching too.
Again, about 30 seconds. It looks the same. So it's zapped once again. Did the same thing happen to the bouncy balls that happened to the elastic bands?
No.
Same
but
exact
yes.
thing happened. Very good job. So that is going to be your hypothesis and controlled versus experimental groups. We've been talking a lot about really cold stuff. What's something that's really hot?
Boiling water. Boiling water.
Yes, fire. Yes, so yes, the sun. What are the 3 things that are required to have a fire? What do you have to have? Yeah. Say that last one one more time. You're very, very close. So yes, you need a heat source, you need fuel, and you need oxygen. Yeah. So, but can nitrogen replace oxygen? I mean, they sound the same, right? Like, can they not just like replace one another? What I'm gonna do is I'm gonna grab a little bit of the liquid nitrogen here.
But what is she about to do?
So, for a fire to work, you have to have oxygen. But I think they sound the same, so I mean, I don't understand why not, like, just having oxygen instead. Hold on. So I have this fire lit right here. And I have my heat source, I have my fuel, and right now I have oxygen. There's oxygen in the air around us. But let's see, will the flame grow larger if I place it near the nitrogen? Let's see what happens. Oh man, I lost my fire. So can nitrogen replace oxygen? No, it cannot. You have to have oxygen to have a fire. So if you deplete that source, and the closer I move it to this liquid nitrogen, the more I'm depleting it, the more like it's going to take out that fire. So who remembers what temperature water boils at? Yell it out to me. Yell it out. And what is liquid nitrogen boiling at? Yell it out to me. There we go. Negative. So that's about a 500-degree difference. Well, this entire show, I've been boiling some water behind me. So I just want to see what would happen if I combine it. Now, I want to remind you to please stay in your seats. Just want to say that. Okay. So again, a 500-degree difference. We have water boiling right here that I just poured in. And now, are we ready for the finale?
Yeah.
3, 2, 1. And it looks like I just cooked up a cloud. So with this 500-degree difference,
That's like cool down.
It's
we're getting
cool.
this combination of hot and extremely cold. It's turning that liquid
I'm cold.
into a gaseous state.
Yeah, switch
and
that.
it's
Switch this side.
the room.
Huh?
And you can put up your own
Why?
liquid. Isn't that neat? It is very good job. So that is the end of my show. Thank you.
Woo!